Hello and good morning, dear students. So welcome back to the online class. Today is 28th of July, okay, and we are still doing exercise 8.7. Yesterday I've told you we have to select some questions according to the reduced syllabus, okay, because there are many questions which we have not done, means some of the exercise we have skipped. So on the basis of that we have to choose only those sums which we have to do, okay. So question number 10 is integrate 1 to 3 cos log x divided by x dx. If I remove the limits, if you remove the limits, this question we have already done in the previous exercise when we did indefinite integral by substitution, isn't it? So you will substitute log x as p, okay? So pause the video till here, I'll show you the process now, okay? Alright, so now as I have told you already, the substitution is log x, so assume p equals log x, dp by dx 1 by x, cross multiply with dx, we get the value for dp as 1 by x dx, so dx by x is dp, okay? So now we have to change the limits. When x equals to 1, p equals to log 1, which is 0, and when x equals to 3, p equals to log 3, okay? So new lower limit, new upper limit. Therefore this whole integral becomes 0 to log 3, upper limit, lower limit, okay? Cos, this is p, and dx by x is p. So integration of cos p. So what is integration of cos p? We know integration of cos p is sin p 0 to log 3. So upper limit minus lower limit, that is log sine of log 3 minus sine of 0. So sine 0 is 0. The answer will be sine log 3. Please pause the video and note it down. Alright, let's move ahead. Question number 10 part 2 is a similar type of question. I've already done out here. I'm going to explain you now. And from here, you will have to proceed yourself. Okay? Please get the answer. Now come back, focus on this question. The question says integration 1 to 2, lower limit, upper limit. We are aware of this now, isn't it? Dx by x and 1 plus log x. Just by looking in the question only, I hope you have guessed this assumption, substitution. P as 1 plus log x. Same thing, 1 is 0, log is 1 by x. So you cross multiply, you'll be getting this. Now comes the limits. When x equals to 1, log 1 is 0. So therefore only p equals to 1. Okay, this is 0, 1 plus 0 is 1. When x equals to 2, log 2, it remains as it is, p equals to 1 plus log 2. So therefore I get integration, lower limit 1, upper limit changes from 2 to 1 plus log 2. This dx by x is dp. This is p square, take it up, p to the power minus 2. Now this becomes p to the power minus 1 divided by minus 1. Take it outside and put the limits, you get your final answer. Please pause the video and complete this as well. Okay? Alright, let's move ahead with question number 11 part 1. Question number part 1 is integration 0 to pi by 360. The question is sec x into tan x divided by 1 plus sec square x dx. Okay? Now, in this type of question, how to take the substitution, let us check. If I put the denominator, then I'll be getting 2 sec x and sec x into tan x. That will be another problem, isn't it? So instead of taking that, you can start with the assumption p as sec x. Okay? You try yourself as other assumptions also, and then come back out here. Okay? You'll verify yourself. So p equals to sec x. So when p equals to sec x, dp by dx is sec x into tan x. Cross multiplied, you'll be getting sec x tan x dx, which is my numerator. And this becomes 1 plus p square. So not a problem. Okay? So when x equals to 0, p equals to sec 0. Now what is sec 0? Opposite of cos 0, isn't it? So what is cos 0? So cos 0 is 1, so sec 0 has to be 1. When x equals to pi by 360, so therefore p equals to sec 60. So sec 60 is opposite of cos 60. So what is cos 60? Cos 60 means half. So hence this will be 2. I hope you are clear till here. So now therefore the whole integral becomes lower limit 1, upper limit 2. The numerator sec x into tan x dx. Sec x into tan x dx is dp. Right? And therefore this is 1 plus p square. I hope you know this integral. 1 to 2 dp by p square plus 1 square. Seventh standard integral is a tan inverse. So therefore this is tan inverse of p divided by 1, which goes from 2 to 1. So therefore this is tan inverse 2. minus tan inverse 1. And we know tan inverse 1 means 45, isn't it? So tan inverse 2 minus, because 1 is tan pi by 4, hence it will be only pi by 4. So please pause the video and go line by line. Okay? I hope when you check the answer you don't get this answer. Okay? The reason is because here I've just put the values directly, isn't it? But here I can also use the formula of tan inverse x minus tan inverse y, tan inverse a minus tan inverse b. Okay, so either you keep this as the answer, and if you want the book answer, what we need to do is we have to use the formula out here. See, tan inverse x minus tan inverse y, tan inverse x minus tan inverse y. So right from here, if I use this formula, what will I get is tan inverse, what is the formula? Tan inverse x minus tan inverse y, tan inverse x minus y divided by 1 plus xy, isn't it? So x is 2, y is 1 divided by 1 plus x is 2 and y is 1. So therefore this will be tan inverse 2 minus 1, which is 1, and 1 plus 2, which will be 3. So hence this is your answer. You can keep it till here. You want to get this, then use this formula. Okay? The reason we have not used this formula is because we have not done the chapter of inverse trigonometric function. So when you do that chapter, then you will be clear with this formula as well. Okay? So pause the video and note it down. Okay, let's continue with question number 11, part 2 now. The question is integration 4 to 8x into, now there is cube root. Can you see the cube root? Cube root of x minus 4. So whenever there is cube root, if there is square root, p square. If there is cube root, then p cube. That is the substitution. Okay. So pause the video. I'll show you the steps. Alright, let's proceed. So as I said, when there is a cube root, assume this as p cube. Okay, if there is only square root, then it becomes p square, right? So substitution p cube, differentiation 3p square dp by dx equals to 1. Okay, so cross multiply, you'll get 3p square dp, which is equal to dx. So I hope everyone is clear till here. Now comes the limits. So when x equals to 4, when you put x equals to 4, p cube equals to 0, isn't it? So p equals to also 0. When you put x equals to 8, so p cube will be 8 minus 4, that is p cube is equals to 4. So p is equals to 4 to the power 1 by 3. That is cube root of 4. Okay, so this is the first part. Now when I put the limits back, therefore integral becomes 0 to 4 to the power 1 by 3. This is the limits. 0 to 4 to the power 1 by 3. X, what is the value for x from here? X is p cube plus 4. What is the value for x? You can see out here p cube equals to x minus 4. So what is the value for x? P cube plus 4. X is equals to p cube plus 4. This is cube root of, what is the value for x minus 4? P cube. This is p cube. And what is the value for dx? 3p square into dp. Please mention 3p square into dp. Now what happens out here is this p and cube, this cube and cube root gets cancelled out. So therefore I get 0 to 4 to the power 1 by 3. And this becomes p cube plus 4 into only p, because cube and cube root gets cancelled out, and into 3p square dp. So now pause the video, note it down, and I'll show you the next of the steps. Alright, the reason I'm not showing the steps is because if I write everything in the video and then explain it, the video is going to be very lengthy. Okay, so I hope you're clear till here. 3 constant, p square into p cube into p cube plus 4, multiply term by term. When you open the bracket, you'll be getting p to the power 6 plus 4p cube. Okay, so which comes out here. Take the integration, p to the power 7 by 7 plus 4, p to the power 4 by 4, 4 gets cancelled out, so I get this. Now what to do? Put the upper limit and then we put the lower limit. See, when I put the upper limit, this will be p to the power 1 by 3 into 4 to the power 1 by 3 to the power 7, 4 to the power 1 by 3 to the power 4, and then 0 we don't have to. Okay, so pause the video, note it down, I'll show you the steps again. Alright, please come back out here. So till here, we're in the last part. Okay, so now put the upper limit and then put the lower limit. So when I put the lower limit, it is both 0. When I put the upper limit, see, in place of p, I have to put 4 to the power 1 by 3. The value for p is 4 to the power 1 by 3 and to the power 7 is there. So total I'll be getting 4 to the power 7 by 3 by 7 plus 4 to the power 4 by 3 and minus 0. Okay, now this 4 to the power 7 by 3 I can break it as in this way. 3, 3. Box bracket, 4 to the power 7 by 3. Can I write 4 to the power 1 into 4 to the power 4 by 3? This is the product law. I can break the power in this way. Multiplication, the power gets added. 1 plus 4 by 3 is 7 by 3. Okay, you can take the LCM also. And plus 4 to the power 4 by 3. The reason I'm doing this is because I can take 4 to the power 4 by 3 common, which is this 4 to the power 4 by 3 common. So 3 into 4 to the power 4 by 3, remaining 4 by 7 plus 1. So 4 by 7 plus 1 means 11 by 7, isn't it? And here, again I can write 4 to the power 4 by 3 as 4 to the power 1 into 4 to the power 1 by 3 using the product law. Okay? So now, 4 3s are 12 into 4 to the power 1 by 3, this is cube root of 4, and into 11 by 7. Just multiply 11 into 12 is 132 divided by 7 into cube root of 4, which is your final answer. So pause the video and note it down. Alright, let's go to the next question. It's a bit easy type of question. Number 14, 0 to half sine inverse x by root 1 minus x squared. Just look at them, the numerator and denominator. There is a relation. Sine inverse x differentiation is 1 by root. So assumption is p sine inverse x. dp by dx is this. So dp equals to dx by this. So dx by this is dp, no doubt. Now I have to put the limits. When x equals to 0, p is equals to sine inverse 0. Now sine of which angle is 0? 0. So hence the value is 0. So lower limit is 0. When x equals to half, p equals to sine inverse half. Now sine of which angle is half? Sine 30 degree. That is pi by 6. So sine inverse sine pi by 6 will be pi by 6. So lower limit, upper limit. Clear? Pause the video till here and make it clear till here. Okay? Great. So therefore, after putting the limits and putting the substitution, we will be getting integration. Lower limit is still 0, but upper limit has changed from half to pi by 6. Okay? Sine inverse x, according to assumption, is p. dx by root of this is dp. So therefore, it's very simple. P square by 2, 0 to pi by 6. Whatever is the constant, please take it outside. That is half. And then we put pi by 6 whole square minus 0 whole square. Now this is pi square by 36. 36 with 2 is 72, which is your final answer. So please pause the video and note it down. Alright, next question is number 12 part 1. So number 12 part 1 is 0 to 1 tan inverse x dx. Now if you see this properly out here, again it is in the form of ILATE. So which comes first? Inverse, and then algebraic is the second function. Here it is only tan inverse x, but I have to write tan inverse x into 1. Okay? So therefore this is your u and this is your v. So we are doing integration by parts. We know it clearly. So u integration of v minus integration differentiation of u into integration of v dx. Okay? With the limits from 0 to 1. Now see what happens. This is x into tan inverse x. So x tan inverse x is the first part minus differentiation of this is 1 by 1 plus x squared and integration of this is x. So altogether it is integration x by this, isn't it? Now there's a problem what to do, because for this integral we have to take the assumption we cannot do directly. So we'll separate the first part and the second part out here. The first part is x tan inverse x 0 to 1, the same limits, and minus integration 0 to 1 x by this. Okay, so first we'll solve this. So when I solve this, then I'll be getting, put x equals to 1. So therefore 1 tan inverse 1, isn't it? 1 into tan inverse 1 minus 0 and 0 to 1 x by 1 plus x squared dx. Okay, tan of which angle is 1? 45. So this 1 can be written as tan pi by 4. Tan inverse tan pi by 4 is only, so I'll be getting pi by 4 and minus 0 is, keep it as it is, and therefore this is 0 to 1 x by 1 plus x squared dx. Okay, let us keep this as it is. Let us keep this as I. I want to keep this as I. I'll find the value of I and put it back out here. Okay? So till here, pause the video and note it down. Alright, so therefore, till here we have done. So I am keeping as this integral 0 to 1 x by 1 plus x squared. Substitution we know because the power in the numerator is less than the power in the denominator. So we have to make the substitution, which is dp by 2 as this. Now the limits, when x equals to 0, p equals to 1. And when x equals to 1, p equals to, oh, sorry, not root 2. P is only 2, my mistake out here. P is only 2, so here P will be 2, then this will be 2, this will be 2, as well as this will be 2. Okay, okay, so when x equals to 0, p equals to 1, and when x equals to 1, then p will be 2. Okay, so therefore the whole integral becomes, this I becomes 0 to 2, sorry, oh my goodness, this is 1 to 2, keep it as 1 to 2, okay, so dp by 2 divided by p, 1 by 2 is a constant, this is 1 to 2 dp by p, right, so half, which is log 2 minus log 1, in fact you'll get the same answer because, the same value, because log 1 is 0, so hence you'll be getting this as half log 2. So now finally what we'll do is we'll put this value out here. So therefore, the final step will be, if I keep this as equation 1, therefore from 1, what I get is pi by 4 minus the value for this was I, and the value for I we got is half log 2. So pause the video and note it down. The value for this integral is pi by 4 minus half log 2. Okay? Alright, therefore your assignments for today will be question number 14 part 2, okay, which is same as 15 part 1, and then 16 part 1 and 16 part 2, the hint is given out here. See, the question is 0 to 1 cos inverse 1 minus x squared divided by 1 plus x squared. Actually this is the formula of 2 tan inverse x, and this whole solution you'll be getting in example 15 part 2, page number 7, 8, 9, just few pages before, check it. Similarly this, again this is the formula of 2 tan inverse x, so therefore you can see this and this is exactly the same. So if you can do this, then no doubt you can also do the same thing, and this one is as well as homework. So 3 questions, same, okay, it's already done in the book. The only one question that you have to do is this one's, okay, 17, 0 to 1, assume tan inverse x as x and then proceed, okay. So we have completed this exercise so far, and from the next class we'll have to start properties of definite integral, which is very, very important for IISc. So I want you all to complete this today's class along with the assignment and submit by tomorrow. Thank you. I'll see you in the next one.